Welcome to the Maharashtra State Board of Technical Education, coming with the lead Learning at your doorstep. Name of the course is Utilization of Electrical Energy. Name of the unit is Electric Drives and Elevators. Unit outcome is recommend relevant motor for the given application with justification. In today's session, we will learn the application of various electric drives in industry and domestic purpose. The key takeaway of the session is selection of motor depends upon so many factors like nature of load, starting condition of load, matching of speed torque characteristic and electrical characteristic of. Learner may pause the presentation and can go through the concept map. Before we decide the type of electric drive, we have to understand the nature of load. There are four types of load. Number 1. Load torque is constant. Load torque remains constant irrespective of speed. For example, hoist, crane, etc. Number 2. When the torque is directly proportional to the speed. Example is the fluid friction where the lubricant is used. Number 3. When the load torque is directly proportional to the square of the speed. It happens with the air and the fluid friction, that is in the blowers, fans, etc. And the fourth category, in which the load torque is inversely proportional, that is load torque decreases with increase in the speed. So first of all, we have to understand the nature of load. Starting condition of the load. The starting torque requirement is different for the various applications. Starting condition of load is very important while selecting the motor. If we see the example of electric traction, conveyor belt, hoist, etc., the starting torque required is large and it should be provided at the low speed as well. On the other hand, if we see water pump, lathe machine, drilling machine, etc., starting torque requirement is medium. So, while deciding the size of motor, accelerating and the braking torque also have to be considered along with the full load torque requirement. The next important point which is to be considered is the matching of speed and torque characteristic of load and motor. For the stable operation of motor, if load torque demand increases, the motor speed decreases. The decreased speed causes motor to take more current from the supply. So the input power increases and motor torque increases, and motor meets the increased torque demand, and of course reverse will happen if the load torque demand decreases. So motor load system will operate in steady state only when motor torque equals the load torque. It is called the equilibrium point. In the diagram, it is shown that for the stable operation, load and motor characteristic should intersect at exactly 90 degrees. Only then both will be equal. Now, electrical characteristics of electric drive. The success of an electric drive for any purpose mainly depend on its electrical characteristics under normal operating condition. These are running characteristic and the starting characteristic. The running characteristic is nothing but the speed torque characteristic. Next, the power factor, magnetization component of current which occurs in AC motors only. These are also to be considered. In the diagram, the DC shunt motor and the series motor speed torque characteristic is shown. DC shunt motor is slightly drooping in the nature. So, a shunt motor is considered to be a constant speed motor for all practical purposes. On the other hand, DC series motor shows a series characteristic, so its speed falls as the torque increases. In the diagram, speed torque characteristic of three-phase induction motor is shown where the T represent the torque, TST represent the starting torque, Tm represent the maximum torque. What is S? S is the slip of induction motor. The formula is Ns minus Nr upon Ns, where the Ns is the synchronous speed of rotating magnetic field measured in the RPM and Nr the speed of rotor. There are two types of three-phase induction motor, that is the squirrel cage and the slip ring induction motor. The torque, it can be adjusted by changing the resistance of the rotor circuitry, which is only possible with the slip ring induction motor. So, in order to get high starting torque, the slip ring induction motor is invariably used, started with a variable resistance inserted in the rotor circuit. On the other hand, squirrel cage are fixed at both ends on the rotor, so no change in the resistance can be done. Now if we talk of the single phase series motor, so first of all, the single phase induction motor, they are not of the self-starting type. So there are some techniques which are to be adopted in order to start the motor. The resistance split phase motor, when only the main winding is used, it doesn't give a good starting. Therefore, with the help of auxiliary winding, sufficient torque is developed and the starting torque can be raised more than 150%. In capacitor start single phase induction motor, by using capacitor in the auxiliary winding, the starting torque can be raised up to 350%, which is only in case when capacitor is not used. This is how torque can be adjusted. Till now we studied about the electric torque characteristic of various drives, that is a three-phase induction motor, DC motors, single-phase induction motor, etc. So every particular electric drive is useful for a particular kind of load, like small universal motor are useful for the domestic appliances which include the mixer, hair dryer, electric shaves, vacuum cleaner, etc. Now the capacitor type single phase induction motor is useful for the washing machine purpose and the room cooler purpose. The single phase synchronous motor are suitable to electric clock and other timing devices. The permanent split capacitor type and the shaded pole single phase induction motor is useful for the table fans and the ceiling fans. Then refrigerator and air conditioner capacitor type single phase induction motor is used for the small unit, and the three phase squirrel cage or the slip ring, it is used for the larger unit. So learner may go through the list and note down the particular type of electric drive which is recommended for the particular domestic purpose. Here is a list of application of drive for the industrial purposes. Learner may go through the list for the various industrial purposes and the electric drive recommended. Here we see that DC series motor or the three-phase slip ring induction motor is recommended for the heavy starting application like the cranes, lift and the hoist. On the other hand, the DC shunt and the compound motor are recommended where the torque of a constant nature is required like in machine tool, lathe, milling machine, polishing machine, etc. Also, for the motor generator set, synchronous motor, they are recommended. In the printing machinery, DC compound motor, AC commutator motor, squirrel cage and the slip ring induction motor are recommended. In the industrial fans and blowers, three-phase slip ring induction motor are recommended because it gives heavy starting torque. The learner may pause the presentation and can go through the quiz, and after that can cross-check the answers. In the today's session, we have seen that the selection of an electric drive depends on nature of load, starting condition of load, matching of the speed torque characteristic and electrical characteristic of motor. So, study of the feature will help us to decide a particular electrical drive for a particular application. In order to revise the points which are covered in the today's session, learner may go through the following books for the further reading and learning. Thank you very much.